Let's do assignment 4. It's called adding vectors, part 2. What we're going to be doing in this assignment is we're going to be adding vectors, but we're going to be adding vectors that aren't necessarily lined up with the x and y axis like we did with the last assignment. If you notice in adding vectors 1, vector A and vector B, one of them lined up with the x-axis or with the y-axis, but now we're going to have vectors that we're going to add together that have components in both the x and y direction. And we're going to learn how to handle that. So, for example, let's take a look at vector A. Let's say vector A looks like that. And let's give it an angle. Let's say it's like 30 degrees. And let's give it a magnitude of 4. Let's say 4 meters. And then we're going to add this to vector B. Well, let's give vector B an angle like that. And let's say it's we'll make it 3 meters long. So this is vector B. And I'm just making this up as I go along. So some of you with calculators, get ready. I'm going to ask you to do some calculations for me. So now I think it's easy to see that A and B, they're both at angles that aren't 90 degrees or aren't 0, or they aren't lined up with the x and y axis. So what do? Well, to add them graphically, we do exactly what we did before. We hook the vectors up head to tail. So I'm going to reproduce vector A right here as best I can. And there's vector A again. Well, you know what? Let's make it a little better. Let's make it actually a little bit closer to 30 degrees. So there's vector A. And then what we do is we take vector B and we stick it on the end of vector A. So here's the arrow, and then this is the tail. So it goes arrow to tail. Here's vector B. Looks like that. And then let me actually rewrite this a little bit. So here's vector A plus vector B. It's exactly what we did before, isn't it? Now what's the answer? Well, the answer is the result of this. You start where A started, you end where B ends. And there's your vector R, like that. And let's see, what did I make this? Should I make this 80 degrees? I don't know. So that's how you add them together graphically. But how do you do this mathematically? Well, if I were to line them up in columns like I did before, where I say, vector A is 4 meters at 30 degrees. Okay, so these are polar coordinates here, right? This is your R, and this is your angle theta, your magnitude. And then B here has a magnitude of 3 meters, and it's at an angle of 80 degrees. Okay, now here's what not to do. When your vectors are in polar coordinates, you're going to be tempted to just add them together. You'll say, oh, well, what's 30 degrees plus 80 degrees? That's 110 degrees. 4 plus 3 is 7. 7 meters at 110 degrees. Wrong, wrong, wrong. You cannot add vectors together like that when they are in polar coordinates. It doesn't make any sense. I mean, if you draw the picture, you will see, look at vector R here. That's nowhere close to 110 degrees. 110 degrees is in the second quadrant. So adding them when they're in polar coordinates is just going to give you a bogus answer. So what do you have to do? You have to add vectors together when they are in rectangular coordinates. So remember that the x here, the x component of a vector is the magnitude of it times the cosine of 30 degrees. And then the y component, see, we want the x and the y components for these vectors. And this is going to be 4 meters times the sine of 30 degrees. And here's where I'm going to need some of you with calculators to help me. This is 3 meters times the cosine of 80 degrees. And this is 3 meters times the sine of 80 degrees. Okay. Now, let's actually figure out what these are. Okay, so we'll just go A plus B. Okay, I'm still on camera. Okay. Well, if somebody with a calculator can tell me what 4 meters times the cosine of 30 degrees is. Anybody do that real quick? Please hurry. 3.5. What is it? 3.46. 3.46 meters. That looks reasonable. Now, I don't need a calculator for this. 4 meters times the sine of 30 degrees. That's 1/2 of 4, so it's 2 meters. I'll put 2.0 meters like that. Now, what is 3 meters times the cosine of 80 degrees? It's going to be pretty small. Somebody calculate that for me, please.
0.52.
What is it?
0.52.
So it's 0.2, 0.52?
0.52.
0.52.
0.52.
And then what is the y value? It's going to be pretty close to just being 3. Everybody get an answer for that? Is it 0.95? 2.95 makes sense. 2.95. These are in meters. Now I'm in rectangular coordinates, and I can add them. Okay, so this is 8, 9. This is 3.98 meters. And this is 4.95 meters. That's my resultant vector in rectangular coordinates. And this is good. Look at the picture. Here's AX is right here. There's AX. And then here's BX. See that they're in the same direction? 3.46. This is 3.46. This is 0.52. Gives me a total of 3.98. In other words, R goes all the way out to here in the X direction. In the Y direction, well, Y goes up, or A goes up 2, B goes up 2.95. When you add those together, you get the total R in the Y direction. Now, it's pretty easy to express my answer in polar coordinates. R is equal to the square root of 3.98 meters squared plus 4.95 meters squared. Somebody calculate that for me. And then the angle is going to be the inverse tangent of the y value, 4.95 meters, divided by the x value, 3.98 meters. I don't have to add 180 degrees. I'm in the first quadrant. So I get my answer, and I'll just write it over here. R is equal to, well, what do I get for my magnitude? 3.98 squared plus 4.95 squared, take square root. And what do I get for my inverse tangent? Claire, do you have it? Oh, see, now you're on. Anybody? What? Okay, we can go a little over. Actually, I can post up to 15 minutes. But what do I get for R?
6.35.
Okay, 6.35. And anybody got theta yet?
51.4 degrees.
51.4 degrees. Does that look reasonable based on my my drawing?
Yeah.
Yeah, that's about right. So there you go. So to recapitulate here, here's what I want you to do on the homework. You draw a picture of it. You take your vectors and you express them in rectangular coordinates. Then you add them together, and then you use Pythagorean theorem and inverse tangent to get your angle. Now here are the 9 problems you are to do. Right here. Notice 1 through 4 are already in rectangular coordinates. It makes it a little bit easier. But 5 through 8 are in polar coordinates, so you will have to convert them to rectangular coordinates before you can add them. And then number 9, I'm giving you 3 vectors to add. You just follow the same process, but you do it for 3 vectors instead of 2. So try that out. Okay? Good luck.